Hello, everyone, and welcome to Nelson's Corner. This is a special holiday issue, if you will, that's not numbered so that no one gets confused with the ongoing Nelson's Corner series, in which we are currently taking a look at design patterns. This is a special Christmas time episode where Nelson's just going to kick back, go over a few things with Zach, and have fun.
Okay.
And speaking of Nelson, he is our host.
He is here. That's
Nelson
right.
LeKay. Nelson.
Hey.
Yeah, as you can see, he's really got the holiday spirit going and going strong.
Not quite a humbug, but yeah.
But, you know, yeah. And Zach is with us.
Evening.
Myself, Jason. With that, I'll turn it over to you, Nelson.
What are we talking about tonight?
A bunch of stuff. People have asked about some of the syntax that we've been using, like the null coalescence or the ternaries, automatic property, stuff like that. And so I just wanted to do a quick video about just, I guess, some loose ends about C#.
Okay.
Yeah, sounds great.
Sounds awesome.
Near the end, though, it would be cool. Some of the stuff that we're going to cover will give us enough background to re-implement a few of the link to objects operators. So
Nice.
maybe we can go ahead and do some of that, too.
Sounds fun.
All right, so first, automatic properties. And I know that most of you probably have seen this, and I know Zach's seen this. But that is an automatic property.
Okay. The fact that
So-
it's already got the getter and the setter kind of in line with it?
Well, they're generated by the compiler. And
Okay.
it's always important to be able to determine if a feature is a feature of the CLR, of the BCL or base class library, or it's a feature of the C# compiler itself.
Did I just go into the freaking military? Don't spout off a whole bunch of bloody acronyms at me. Tell me what they mean.
We're gonna talk about the BCL here soon, but the CLR, like the runtime, the IL that gets the intermediary language that gets generated by the C# compiler and goes into the CLR when it's executed and compiled to assembly when you launch the executable. And some of the features of C# are actually CLR features, but most of them are language features. So basically, the C# compiler looks at the syntax and generates some code for us behind the scenes. And we're going to be looking at a few of those instances in this video. So I'm going to go ahead and compile this. So Control-Shift-B, and then head over to a program called Reflector.
Actually, can we do this, Nelson? I have an idea. You've got first name set up. How about set up last name? But let's go ahead and create our own accessor methods. There we go. Sweet.
There's
Just-
ReSharper for us.
Yep. Making life nice and easy.
Okay, so I can go ahead and compile, so Control-Shift-B, and I'm going to head over to Reflector. And Reflector is a great tool for learning what the C# compiler does behind the scenes. So to launch it, you just go ahead and download it. It's free, but they do have a version you can pay for. That's decline.
Sorry, that's funny.
His buddy's on the other end going, I know you're recording right now. Answer.
Yeah, there's a non-free version that integrates directly with Visual Studio, but you can go ahead and get the free version, just unzip it anywhere on your computer, and run the executable. And it's,
Zach, have you ever seen Reflector before?
I know vaguely what it is. I'd heard that it's like a decompiler.
Yeah.
That's the word that I've associated with it, is decompiler.
It has a decompiler in it.
Okay.
At the base level, it's a disassembler, so it looks at the executable and reads out the IL.
Mm-hmm.
The IL being the intermediary language, as well as all the metadata that's associated with the assembly, such as class names and stuff like that. And then it also is a decompiler, so it interprets that IL and gives it back to you.
Okay. So how would you define Reflector? What would you say it is?
It's a thing that does stuff.
Excellent. I'm going to write that down in my notes. It is a thing that does stuff. Happy holidays.
Okay.
It's an awesome way to look into assemblies and take a look at source code, as long as it's not been obfuscated.
Right. So we can go ahead and do some cool things like, if you ever wanted to know how the console class was implemented, and it's in MS Core Lib, sorry, on system. So for example, I'm sitting here going through these assemblies that are part of the .NET Framework itself. So I clicked on the assembly, went into the namespaces under System. There should be a console guy over here, and he's going to be filled up with a bunch of static methods, or static fields and static methods. And then we can go ahead and find like WriteLine or something, because we use this method all the time. So here's like the WriteLine string WriteLine, and we click on it, and we get the actual C# 2.0 source. It's not actually the source code; it's the decompiled source. But it turns it back into C# for us. So let's bring it up to 4. You can choose which language you want it to decompile in. Like if you wanted to look at this in F#, you'll see that some of it can't be decompiled, but we can turn it into the IL, which is the actual IL that's being run, that the C# compiler turned this into, and we can look at the C# interpretation of it, and we see that WriteLine defers to out.WriteLine, and that's kind of an interesting point. So WriteLine is really just an alias for this out variable, which is a text writer. So if we go ahead and look at out, we see its implementation. Then we can go into text writer, and we can look at its write method. So you can just dig as far as you want into anything that's been compiled in C#. So there is the source code for every time you write line to the console. Or actually, the out variable is a abstraction over the console. But if you wanted to look at your own assemblies, if you were wondering what the C# compiler does behind the scenes, just go ahead and open and find the application somewhere.
You're there. Console application 5 is the one you're in.
Oh, okay. So go into your executable, and we see it's here. Let me refresh because that guy was already there. Okay, so we can go into our application, and we have a console application 5 namespace with our person class and our program class. So if you look at the person class, we see that it has... Well, let me... The reason it's doing this is it's detecting that this is an automatic property, and because we're in .NET 4, it's going to go ahead and break it back into what it would look like in C# and not give us an actual representation. But if we go into 1, we see that there's still only... Oh yeah, because you have to click on the thing. So you see that there's a compiler-generated attribute on our k_backing field, or our bracket first, or whatever symbol, first name k backing field, which is an automatically generated field that holds the data for the last name or property, or the first name property, sorry. And if you click into first name, you'll see that the getter and the setter just return that backing field and set it to something.
Gotcha. So, but the key thing here is to take a look at what it generated. Basically, you'll see both the get and the set right there. So get is going to return this, so it's going to return that backing field that's going to hold the data that's actually been, given into it, and then set for setting it with the value there. So get. So here's the key thing I just want you to look for. Being still relatively new to this, you see a get and it's returning. You see a set, and you see that the backing field is being set to whatever value is. Now, Nelson, show him the old way of creating the accessor methods that you did for the last name.
Yeah, if you look at the last name, you'll see basically just the code that we have.
So this is the code over here on the left-hand side, and for those of you that are watching this video, you can't see obviously what I'm pointing at, but I'm pointing to the left at Visual Studio to lines 8, 9, 10, 11. So right here we see that we're defining our property last name, and here we are with the same thing, get. It's returning what's being stored in our private last name member, and it's setting and last name equals value. So you see basically it's got a get and a set, and just like the other one has a get and a set. But the key thing to note is that using this automated approach, the compiler is going to set up the getter and the setter for us on the back end, and it's just a much quicker way of implementing properties where you don't have to go through and implement your own getter and setter every single time, because most of the time that's what you're going to do. You're going to create a backing field that's going to hold the data in it, then you're going to put a getter and a setter. There are times that you may want to put functionality into a property. So as soon as you want to do that, you're not going to use any automated approaches. You're going to actually define the property yourself.
Gotcha.
Yeah. And generally you won't see me except for in maybe a DTO or basic code, you generally won't see me put public getters on properties, because remember, properties expose state, and allowing, in an OOD philosophy, allowing external sources to mutate state can lead to issues, I guess.
Did you say private on get?
No, private on set, I mean.
Okay,
sorry.
that's better. Yeah.
So generally what I'll do is this, which is equivalent to if I had done this.
Right.
And all that does is makes these no longer settable from the outside world. So I can go ahead and instantiate a person. And first name and say equals. And you'll see that throws a compiler error. Because it's a private.
So in this case, he may want to create a constructor that's going to take up a first name in. And then, of course, the constructor is internal in this class. So it has the right to call upon that and use it. So yeah.
So now you set it. And yeah, so I generally do avoid public getters or public setters, but yeah, that's kind of a OOD topic, I guess. So yeah, so you do like automated properties, Zach?
It makes sense so far. It's just
You love them. Come on, admit it. You
Yes,
love
do I
them.
like them? I mean,
Yes, you like them.
I do, man. I freaking love
It's
them.
less typing.
I'm so excited.
It's less typing.
Yes, less typing is always the best. Okay, so next, structures. Do you know what a structure is?
Without automated properties, I'm sorry, I didn't mean to cut you off, but without automated properties, it leads people into being lazy. I've seen this so many times, and maybe you have as well, Nelson, with other people. But what you end up finding people doing is, instead of creating their backing field for the data and then making the property, they end up just saying screw it and start creating a whole bunch of public fields that just can be accessed. It's because they don't want to take the time to write the extra code, and you really should create a proper interface through properties for the data that needs to get stored or retrieved.
I'm with that.
Have you seen people being lazy doing that?
Yeah, I have.
And that's really bad. You just don't want to do that.
All right. Well, yeah. So to demonstrate structures real fast, I'm going to go ahead and turn this into what would be called, well, it's not really an entity because it doesn't have an ID, but we're going to have a set name. And this method, being a behavior, is going to basically just do this. And this does... this does look kind of ridiculous, probably to someone who doesn't do or hasn't looked into a lot of OOD. But basically what we've done is we've really segregated the responsibility of setting state to a behavior on the method, and the method itself has every piece of information it needs to perform its operation. So instead of setting first name and last name external to the person, we're now invoking a set name behavior on the person that takes a first name and takes a last name and sets it internally. But in addition, we could also enforce invariants, such as, you know, if the first name length is 0, or the last name length is 0, we can, where's blank? Doesn't work. We can just, you know, throw a new exception. We can enforce the constraint that these two values have to, you know, be greater than 0.
Mm-hmm.
And you'll generally see me do a lot of this where I create a specialized method per operation that needs to be done on a class, and it sort of funnels your interactions with the class and gives every single interaction with the class semantic meaning. Because instead of just
but speaking of semantic meaning, we're talking about structures, yeah?
Yeah, we are.
So give me a general definition from which I can start to take everything you're saying and start plugging it into to make all this make sense. What is a structure?
I was just about to get into structures.
Okay.
Right after I got done with that spiel. But you'll notice that there's a string first name, a string last name, a string first name, a string last name, and it's just annoying, you know?
Mm-hmm.
This is actually, it's really just a name. We split it into first name and last name for, I guess, convenience or whatever. It makes more sense from an application standpoint. But we could create a class with a first name and last name and have the person be a composite of that class, but this doesn't really feel like something that should be, well, a class. It's not a very big concern. It's more of a DTO. It's just a small object, small throwaway object to transfer data. So a structure is generally, I know I'm defining this in a roundabout way, but it's generally used in areas where you need to transfer multiple simple values with semantic meaning. Those simple values right here being two strings, and the semantic meaning of these two properties being, well, a name.
Mm-hmm.
And you define a struct just like you define a class with the struct keyword. We're going to call him name. And you can give him, well, you can give him everything a class can have. You can give him a constructor. Well, I'll actually talk about that in a second. You can give him properties, events, fields, and methods. And you can implement interfaces with the structure, but you cannot inherit with a structure. So a structure cannot inherit from another structure like you can with a class. But again, you can implement interfaces. And there's a few interesting things about structures. You'll hear them called value objects a lot. And value objects, if I'm not mistaken, that actually comes from the DDD definition of an object that, now I'm going on the philosophical side again, but an object that doesn't really represent behavior, or it doesn't really represent business logic or behavior or anything. It just contains state and it moves it around. And then the value object, you'll hear that, like I said, associated a lot with the structure, and that's sort of the definition of that. There's some interesting properties about structures, not to be confused with properties in the property sense. But if I go ahead and do do this real fast, you'll notice something weird about this. All right. So given everything that we've defined so far, what do you think the output of this program will be?
I don't have any idea. I was trying to follow it while you were typing, and I got way left behind.
Okay. So we defined two methods, mutate person and mutate name. The mutate person takes a person object and calls a method on it. Mutate name takes the name structure and mutates its state, sets the first name and last name to something else. And then after we invoke these two methods on their respective objects, we write them out and then we wait for a key. But the output of this program would probably surprise someone. If you kind of read it sequentially, you'll see mutate person. Okay, it takes a P1, which is a person. It sets the name to something, and then it returns. So obviously, right line P1 first name is going to be Nelson. But when we instantiate this name structure and then call mutate name on it, we do pretty much the same thing, but the output isn't going to be what's expected. Because if I go ahead and run this, you'll see that.
Where let's give Zach just a second to take this in. Where I just to see just to point this out, Zach,
Mm-hmm.
and that is that right here with his new person, he called mutate person. So we're down here at mutate person, sending in our person, which is P1.
Sure. And
And
changing
then
its name
he's
to Nelson.
changing its
Okay.
name.
I'm fine with that.
So, and then when he printed that out, or he echoed it out, it said Nelson.
Sure.
Then he turned around and he created a new name. Now this is a name structure, and he set its first name and its last name. And then when he told it to mutate the name, so name is what's being sent in here, name structure, and he set its first name to Nelson, last name to LeKay. But then when we return back, when he wrote that out to the console, it was still whoa. And what he was saying that people may find surprising that's new to this is, whoa, shouldn't it have
should be
been
Nelson?
just
Gotcha.
like the first one?
Yeah.
There you go.
And to anyone wondering about that, kind of hopefully lose someone's mind, you can equate it to something like this.
While Nelson's typing that now, I know
Reorder
you're
stuff.
not sure why, but what I said, I mean, just the flow
Yeah,
of
I
trace
see.
makes
Yeah,
sense?
now that
Okay.
it's been walked through.
Now, I understand you still don't know why, or it wouldn't make sense why,
Sure.
which is what we're getting to. We're in no hurry here. I want you to be awesome at this.
Well, that was less of an example and more of a, you want to know about building airplanes, here's a 747.
Sweet.
I'm sorry, Zach.
It's okay. Nothing to apologize for. It lost me for a minute, but I'm back up now.
Yeah, it's hard to explain, especially the reasoning behind this, but you just kind of have to see it.
Mm-hmm.
And hopefully with this mutate int example, it might become more clear.
So let's slowly back up and now show him what you add. So he's added a new static method in.
Yep.
So mutate int, it's going to take in an integer, and he's going to set that integer that comes into 10. But now if we step back up to line 42, he's going to create a new variable that's holding an integer. So he's holding 5, and he's passing that guy. So I'm going to grab the mouse just so anyone else can see what I'm pointing to. So now he's got this guy set to 5. So now he's going to pass that down here, and we're going to change it to 10. So then when we return back here, when we write that out, what do we expect to see?
Well, you expect to see 10 because you've changed it, yeah?
Okay, and that's, I'm actually very glad you said
Yeah.
that. We're not going to see
Right.
10. Go ahead, Nelson.
Apparently you're still going to see 5.
Yeah. So if you look at it, you see 5. And the reason that is because value objects, and int is a value object. Value objects are passed by value, not by reference. And you can kind of underscore that by taking out this variable declaration and replacing it with just 5.
Sure.
The fact that this code still compiles obviously means that none of this state mutation is going to represent itself back in the application. Because we're just passing in a literal 5. You know, that doesn't.
Right.
That's a value. You can't set 5 to 10.
And if Zach has no objection to this, and if you don't have any objection, can I let me play a student and ask some of the questions I would, as an instructor, would be anticipating. Is that all right with you
Sure.
guys? So I'm playing the other part of Zach. I'm the evil side. Okay, so you've said value type and you've said reference. So value objects and reference. What does that even mean?
Well, a reference type is a type. A type is anything you can create a variable out of.
So an integer is not a type?
No, it is a type.
But you just said that reference.
No. Reference types
Oh,
are
okay.
types, but value types are types too.
Okay.
But where they differ is when you pass around a value type, it's copied. When you pass around a reference type, a reference to that object still. So when I pass in a reference to this object, so this person, and I pass them into mutate person, this variable right here is still pointing to the same memory
No,
location.
you're getting a lot better. Do you want to go ahead and mention stack and heap?
Yeah.
You can. I don't think it's a bad thing.
Well, see, this would be so much easier to explain in C++.
Come on, Nelson. We're in C# and it's still not bad.
Because in C++ you have to explicitly pass by reference, whereas with C# it's implicit,
Correct.
depending on what kind of type that you're passing around. So the C# compiler knows that this person object is reference type, and it knows that this name object is a value type. And it knows that when someone invokes this method or when someone invokes this method, they expect different things. So mutate person expects a reference to this object. Mutate name expects a copy of this name object. And in memory, if you think about it in terms of contiguous blocks of memory, the memory of person, so the amount of memory that this guy is taking up, which would be 2 references to strings, so that would be 64 bytes plus the, or not 64 bytes, 8 bytes plus the overhead for the virtual function pointer table and stuff. So let's just call it 10 bytes, I guess, whatever. So this is 10 bytes of memory, and it's created somewhere in a place called the heap, which is this, well, I guess it's just a heap. It's this thing that sits peripheral to your program that you can get memory from.
So it's a special area of memory that's going to hold our objects.
Yes, all reference types. So you have this new person class. The new basically instructs the CLR to instantiate this person by first allocating enough memory to hold this person. Mm-hmm. So it calculates the memory based off of all of the fields that it has, in addition to all the magical overhead that every C# class has. And then what it does is the this, for example, the this in this person, which is implicit in this case, mm-hmm. the this variable points to that memory location.
Sure.
It points to that memory location that's allocated in the heap. And when we pass a reference type, well, by reference, which is the only way to pass a reference type, it's not actually copying this memory that's represented by the this variable. It's copying a reference mm-hmm. to the memory referenced by this variable. And so when you say person.setName, when the setName method gets invoked, the this variable inside of setName is still pointing to the same memory location as the this variable outside of this method call.
So you can think of it like a pointer in a way. We're just, I said in a way, we're pointing to something, and then so I'm saying that's it right there. And then if I was to say, all right, Zach, I need you to work on that right there, and I'm still pointing to it, you're going to be manipulating the same data mm-hmm. after you got done and it came back to me. I pointed to a car for you to paint. You went and painted that car. Now you come back to me and say, okay, I'm done. So I continue. The car has been painted. That car has been painted.
Yeah, I'm with that. I mean, I understand.
But that's reference.
Right, that's a reference type. Okay. Where a value type is just making a copy of that value and passing it along.
Well, now you might...
Well,
go ahead.
It's interesting. I don't really want to talk about stack frames, but...
You don't have to get too complicated with it. You can explain stacks very simple.
Well, when a method is invoked, the amount of memory that this method needs in order to exist on your computer and be run. Mm-hmm. So the amount of memory being all the variables. So if I were to declare an int variable, mm-hmm. we've got some strange highlights going on here.
Hey, you're the one that went through my options and like flipped 5,000 different settings.
Hold on, let me close that. There we go. So if we create this variable up here, the C# compiler now knows that this method now takes 4 more bytes. And the reason we know that's 4 more bytes is because int is actually an alias for int 32. 32 stands for the amount of bits allocated for this particular structure. 32 bits being 4 bytes. So we know that when we declare a int variable, the compiler knows that when this method is called, this method needs at least up to 4 bytes to be executed. Mm-hmm. And it's interesting to know that these reference types, they're actually, the references themselves are value objects.
Okay.
A reference is actually literally a memory address. Mm-hmm. So memory is addressed sequentially, starting at 0 and ending at however much memory you have in your computer.
Sure, but you're saying that thing that designates the reference is itself a value type.
Yes.
Yeah.
So this is So when the main method is invoked, it knows that it needs a stack size of, well, here's 2 references. I'm pretty sure the references in, well, at least in 32-bit. Well, are you on 64-bit, Jason?
No, it's 32.
Okay, so each reference is going to be 4 bytes. So right now, main needs 8 bytes in order to be executed.
Okay.
Actually, no, that's actually...
But don't
this
see,
isn't reference type.
Nelson, I love you to death, man, but you're making it too complicated. It can stay simple for a beginner. So you've mentioned reference type, and we've talked about having a heap, which is a special bit of memory that's set aside. So is the stack also like some special memory set aside?
Yes, the stack is allocated on method call.
So
the stack is retrieved from memory on method call. So
the cool thing here is Zach is actually going to start to, if he pays close attention, he'll also start to see how scope really works as well, which is pretty neat. So you have this the stack, special area of memory, that we're going to utilize to work with all of our variables here.
Right.
The variables could be a value type, like an integer that could be holding 32, so 32 is going to be in there. Or it could be a reference type, so it's holding an address that's pointing into what memory, Zach?
The heap.
The heap to where that object is. So 2 types of memory.
Okay, and then so in the heap is allocated on method call, and this is a value type, and we know it's a value type because that little symbol guy right there, and because it's a structure, and a structure is a value type. So the C# compiler knows, the C# compiler knows to allocate enough memory to fit this entire value object on the stack. So this is actually going to be however much memory this guy needs, in addition to the memory that this reference needs. And that's really important to know because this memory that's being allocated is local to this one stack frame. The memory for name, which is going to be the size of two references to strings, so let's just say 8 bytes, is going to be local to main. And if I were to mutate it inside of main, it only makes sense within main because it's just allocated all right there on the stack for you. When we pass it to another function, when you invoke another function, another stack frame for this function gets allocated, and the stack size includes the size required for the element or the arguments. So the stack frame will include enough memory to hold another name, so another copy of that's 2 reference types or 2 references. So that's 8 bytes.
I don't have a whiteboard up, and in the next video we will. So, but Zach, you're really good with.
It's a portion of the stack.
With describing things. So, if you could describe what I'm going to show you real quick.
Sure.
So we start off with main.
Right, which you're
We've got
defining
our
as a
stack
square.
frame, as I'm defining as a square that's holding our variables in there.
Right, of course.
And then when we do a method call, so now we've got a new stack frame. That's gonna it's the size that it needs to be to hold the data that we need to hold for that method. We can't access stuff back here. We're in this block, this stack frame.
Right.
So now we might have, if we're pointing out to the heap, so I'll draw a heap out here. So if we're pointing to an object out here on the heap.
I really need to show everybody what you're drawing.
You like that, don't you?
It's amazing.
Then if we were to pass a reference type over to a method, so now we have a new stack frame, and we have that reference, we're still pointing to that same guy. But if we had an object that was on the stack, a value object, so let's say we had that number 32 sitting here, an integer, and we pass that up here, a copy is made. So now 32 is sitting up here. So if we were to change that value type in this stack frame from 32 to 64 or 100 or whatever, we change it.
It's a copy, so you haven't changed it back
When
in the
we
original.
unwind the stack, when the method finishes and we come back, this is all gone now.
Yeah.
So now we're back in this world. 32 never changed.
Now let's try to explain that in a way that everybody else can see it, because I've got a real unfair advantage now.
Well, I described the entire time. We started out in one block of memory.
Yeah.
We just talk about it in pure memory. And if we were to pass to a method a value type, the value type, that value is copied into this new section of memory. And then if it's changed in there, that memory is just, that stack memory is just kind of like working memory for that method only.
Sure.
We don't access outside of it, except if we're using objects we're referencing on the heap. When we get done and we jump back to the calling method, that portion of stack memory that was allocated, that stack frame, goes away. We unwind the stack back to where we were at,
Right.
which is where we pick back up running in the method that was the caller.
Right.
We don't have, copied stuff doesn't get written back.
Right. I
It
mean,
was its own local copy.
it has its own analogies, like on your computer. If you take a file and you copy it and change the contents of the copy, you haven't changed the
Very
contents of
good.
the original.
Nice analogy.
So,
But if you
Yeah.
were to do the shortcut, if you were to copy a reference of it to another area, and then you double-clicked it,
Right.
it's just a reference, so you are now changing
Sure.
the original one.
so yeah, sorry to.
What? No,
No, it's
this
all
is,
good.
This
It's all
is
good.
all good.
No
and-
apologies
and
needed.
very important stuff.
Well, and like I said, though, C# kind of makes it difficult to demonstrate this because, well, structs and classes look the same. You know. Actually, if you have a constructor, I'm 99% sure you don't need the new keyword. I might be wrong on that one. Must have misread something. Anyway, so yeah, so I guess that's the important thing to know. Have you ever heard of a Stack Overflow?
Other than the website, no.
Well, you want to see a Stack Overflow?
Why not? Nice.
Oh, come on.
There it goes.
Oh, there we go. Oh,
Gotta give it a
there we go.
second.
But you see it executed quite a few times. Actually, I wanted to show the call stack of that. And the reason we get a Stack Overflow, and you'll see something really interesting, is our call stack is going to be huge.
Well, yeah, it's going to infinitely cycle because it keeps calling on itself as its last operation.
Right. So what the issue that's going to do is it's just going to keep on allocating these stack frames until it runs out of memory.
Right.
So that's kind of what there's actually, I believe there's an artificial limit imposed on how many stack frames can be allocated, but the point is that calling methods isn't a free operation.
Right.
Yeah.
Well, let me throw this out there. Since you just mentioned structs, and I think it'll just help me kind of understand. They look, they smell, they talk, they waddle around a lot like classes. Under what circumstances should I be looking at using one over another?
It's generally a preference issue, I guess you could say. It's really philosophical. It's another one of those OOD philosophical type things. And you've been using value objects without really knowing it. Mm-hmm. All the basic objects, in decimal, bool, whatever, they're all value objects. But in addition, there's a date times value object. So if I were to pass around a date time, it would be copied and not copied by reference.
Sure.
But like I said, it's really more of a philosophical statement about the object. It's also a performance thing, because allocating something on the heap takes time. When I do this, when this line of code executes, this memory is being allocated on the heap, and that's not well, it is a ridiculously cheap operation, but not in a game loop or something. Whereas with the value object, with right here, all the memory that's required for this name object is allocated when this method is called, when the stack frame is initialized. So there's no other call to dynamic memory allocation. So it is a performance thing as well. Another quick thing too. Jason's going to hate me for saying this.
I doubt it.
There are times where structures are not passed by value. It's usually when you hoist variables and whatnot.
Let's get to that. Let's get to that later. Let's keep it simple.
I told you, Jason.
I don't hate
so
you.
yeah.
I get into some interesting stuff, but let's keep Zach's head as clear as possible here.
So I like using structures, and it like I said before, it's an OOD thing. Unless you're really concerned about performance and you're doing it for performance reasons, which is important. I mean, if you have a small structure like a vector or a date time or something, there's no reason to waste dynamic memory allocation on that.
And that was your best example right there. when I first introduce somebody to a struct, I say think of it as a lightweight class. So when he said vector, that's perfect.
And I've pulled that much. I mean, that much makes sense, and that's come out of context.
Or a point, and you need to designate an X, Y, and Z location. Then structs would be great to use for basically pulling all of this data together and holding it into what looks like an object, basically. But it's a struct as opposed to a class that's defining this type. So it's like a lightweight class.
Lighter weight in terms of better overall performance.
Performance, because there's no dynamic memory allocation required on the heap.
I imagine not quite the same amount of functionality. Well, I guess it's obviously true because you can't inherit from it.
You can inherit.
No, yeah, and also constructors are limited in weird, bizarre ways. I actually haven't gotten to this part in the C# spec, which I hoped that I had by now, but so I can't, rattle off any deep insights other than to say what I've known to work and what I've known not to work. Constructors, you cannot define a parameterless constructor. The reason is that the
and that's when you're in a struct specifically.
Yes, whenever you're in a struct, because the compiler creates an implicit parameterless constructor that sets every single field in this structure to its default value. And the default value isn't always null. It's null for reference objects, but as you know, the null only really applies to reference objects. The value objects need to be set to something at all times. So a default value for an integer, for example, is 0. A default value for a date time is like, I don't know, I can't remember the date.
Like January 1st, 1970 or 1972 or something.
Yeah. So you can't define a parameterless constructor. And most importantly, you can't... Let's do a... Actually, it's going to be impossible for me to satisfy the constraints of a structure constructor. That's kind of a weird thing to say.
Kind of a tongue twister, yeah.
It's not going to be possible to satisfy this because these are automatic properties. A structure with a parameter constructor requires that you initialize every single field to a value before you do anything. And the problem is that these fields are hidden from us. We can't actually directly access these fields, so we can't actually set them to anything, which means this kind of, if you use automatic properties, you can't use the syntax. But what you can do is you can invoke the default constructor first with this syntax. This basically says, before this constructor happens, go ahead and run the constructor that the C# compiler put together for us. And then come back once all of our values are initialized to their default value. So again, that would be null for reference types, but for an integer, it would be 0. And then at that point, we can do whatever you want. We can set it and all that stuff. So I'm going to go ahead and set these to private. And another thing... no, I'll do this first. So to get on the philosophical side of value objects is there also, like I said, there's a statement about grouping related functionality together. Or not related functionality, but generally related state together. So you see we have this name, and we might use name everywhere in our application, but we're always going to want a first name and a last name, right? And we're probably always going to want a something like this.
Sure.
That's a pretty default sort of behavior for a name, but we don't want to have to redefine this everywhere we need a name. That's just dumb. So we're going to go ahead and replace this implementation with our name. And remember, our name, it's a value object, so it follows all of those same rules. So let's go ahead and do that. Let's give our person a name. Tell them to private set, otherwise other people could set our value object for us, which we don't want. We're going to still give it a... let's just do this. So it's really cleaned up our class a lot, and you'll see me use this sort of stuff a lot, where I kind of break related bits into their own value objects. Sometimes I'll use a class, most of the time I'll use a structure, though. And so we now have our person, and we now have to do this new name. And then we can no longer do this because I made it stuff and things.
You made it stuff and things.
Yeah, it's those really awesome descriptions.
Technical jargon.
Yeah.
That's-
Well, I mean, and it makes it kind of interesting to keep up for us non-technical people, really.
Yeah, I don't think I learned stuff and things until the second year of college.
Yeah. Oh, it definitely sounds like an upper division topic.
Oh, absolutely.
Okay, so we can now work on our value object by passing it like that. But again, this is a philosophical design thing.
Yeah.
This isn't something that's going to magically make your code better. However, it will make code easier to refactor in the future. Because if we decided that we wanted a middle name, for example, we would have to change a lot of code. Whereas right now, we could just change it right here, and then in our we don't even need to change it in the setter unless we want to enforce another piece of validation.
Right.
And here's the kind of last interesting thing about structures is still onto their philosophical
Implications.
implications.
Yes.
Sorry, speaking too fast.
Don't worry about it.
Have you ever heard me say immutability?
I've heard the word, sure.
Generally, I'll make pretty much most of my stuff immutable, meaning that once you create this object, you cannot change any of its internal values, and instead you have to replace it with another one.
Okay.
And that's I don't know. There are a lot of reasons why that has become a trend with the synchronous code, especially. Because you no longer have shared state between two threads, for example. Two threads aren't trying to access the same data at the same time because they can't set anything. It's also a very powerful tenet of pure functional programming, where your program is represented as a pure, I guess you could say, collection of behaviors that don't mutate state, but change state and return that change state, and then another function does something on that. And it's a design thing, and it's turned into a bit of an OCD thing, but it's you'll generally see me make sure everything is immutable, primarily just because I'm used to it. And when I do need to do synchronous code or whatever, I know that this class can't be edited at all. And you'll notice that this isn't something that's really new in the .NET world. Date time, for example, is immutable. If we go ahead and create a date time, we can't set any of these properties to anything. Or we can add a year or add days, and this actually doesn't add days. See what it says? It returns a new date time that adds a specified days.
Gotcha.
So date time is an immutable structure in the BCL or base class library. So yeah, how do you feel about immutability?
Well, it's pretty easy to understand. I love it, man. I got to keep remembering. You're asking me how I feel, man. Immutability is just, it's awesome.
Okay, and you'll also see me do stuff like this pretty commonly. You see ReSharper is nice and does it for me. It's a read-only field. Whenever you see read-only on a field, it means that this value can only be initialized by an initializer, such as that.
Sure.
Or in the constructor, such as that. But if I tried to edit it anywhere else, I would get an error.
So is that how you manually make a value immutable?
Yeah, field immutable, yes.
Field.
Within its own class.
Right.
And I do this a lot as well, because when you have a larger class that has a lot of behavior, and you rely on maybe one or two private variables, you always want to kind of make sure you want the compiler to enforce the fact that those variables will never change, because otherwise it really does lead to a more brittle class. If for some reason some piece of code in that class changes this variable, and then all of a sudden all the methods, all of the behaviors that rely on this variable are no longer guaranteed to operate in the exact same way. So it can lead to really subtle bugs. And that's why I pretty much guard almost everything that I write as immutable.
Gotcha.
Or as read-only, to make sure that doesn't happen.
It's very interesting.
So yeah, and I'm getting compiler error. For some reason, why am I getting compiler error? Oh, because I now it's an age. I don't want to give it an age. So does it kind of make sense? Does the practicality kind of make sense, or you still feel like it's all worthless?
Oh, I never said that, not
Maybe.
once. The only question I had, and I think it's been covered well enough because it's one of those things that changes on a use by use basis, is when one might reach for a struct as opposed to a class. But like I said, I think that's going to be very dependent on the given situation. And when you don't really need all of that class functionality, but you still need something that looks, talks, and walks more or less like a class, then you can reach for a struct.
Yeah, and they're excellent for DTOs as well.
Yeah.
Um,
Data transfer objects. I still remember that one.
yes. Yes, those are structs. How are we doing for time?
Yeah, we can do this. This is actually a good spot to wrap this one up. And if we want to do the next stuff that you had talked about, let's just do a bonus number 2. So that way, our member sponsors can take it bite size and they can choose which ones they want to watch or they want to skip.
Does make tracking through the videos a little easier too.
Yeah. Sound good to you, Nelson?
Yeah.
All right. So we'll go ahead and conclude this video, and then we'll do another one. All right.
Awesome.
Thanks, everyone.
Thank you, Nelson. Thank you, member sponsors.
Thank you, Zach.